Students, here are some examples that I wanted to go over with regards to lessons 4.1 and 4.2, so that if you need like just a voice of explanation on how to do these problems, you can resort to looking at this video. I'm going to start with some of the basics in section 4.1, and then I'll move towards 4.2, and the hope is that you can use this to help better understand what is being required in these two sections. So let's start off with this first problem where they're asking us to multiply these two rational expressions. We have 3 over 5x squared, and we're multiplying it by 7x over 10. Now, one way you can approach this is, straight go ahead and multiply the numerator values and the denominator values and end up with 3 times 7x is 21x over 5 times 10 is 50, and then tag along the x squared. Look to see if you can find any common denominator, common factor that can be divided out in 21 and 50. And there isn't anything that goes into both of them that are like. And the x and the x squared, basically, if you visualize it this way, 21x and 50x squared, 50x squared is just 50x times x. So notice here in this situation that these two x values are going to cancel out, and so you're left solely with 21 over 50x. Okay. One of the things that students are getting a hard time understanding is basically how to get that highest value that goes into the two numbers that are being provided, for example, 21 and 50. Well, what you're looking for is numbers that will go into both of them at the same time. So what can 21 be divided by? Well, 21 can be divided by 1. It cannot be divided by 2, by 3, 4, 5, 6. It can be divided by 7. And the only other one is 21. So knowing your multiplication facts really helps here. But if not, you're going to have to resort to using your calculator. But again, you guys, it just helps with you just knowing your multiplication facts. Start learning them. If you do not know them or you still are very weak, just practice. And so with 50, the numbers are going to be 1, 2, 5, 6, 7, 8, 9, 10. And then that would be it, right? 25 and 50, okay? And you can kind of see the pattern here, right? It's like 1 times 50, 2 times 25, 5 times 10. Those are all the factors. So if you look at 1, 3, 7, 21, and 50 is 1, 2, 5, 10, 25. There aren't any matching values or factors that would divide into both of them other than 1. So that's why 21 over 50 is not reducible. Okay. Now, another approach you can do here is the problem was 3 over 5x squared and 7x over 10. If you see 3 over 5x squared, you can write it as just in factored form, 5x times x. 3 and 5 are prime numbers, and then you have 7x, and then 10 is not a prime number, but it can be broken down into 2 times 5. And once it's written all in prime numbers or prime factors, you can easily see that the x's canceled there, and there are no numerator values that match with the denominator values. So you'll end up straight multiplying across and ending up with the same answer as you ended up upstairs. So let me go ahead and type this in. And all right, let's do another one. It's a little bit more straightforward, and I will spend less time talking through the little nitty-gritty. So 5x squared over 7. When you have a division problem, I want you to change that division problem, and only division problems, into a multiplication, and you are going to multiply by the reciprocal of the other fraction. Okay? So breaking it up into factors, 5 times x over my 7, and then my 8 is not prime, so 2 times 4, and then 7x times x. And again, these two x values will definitely cancel to a 1 with these two. 5, 2, 4 cannot cancel with any of the 7s, so we are done. So if I multiply 5 times 2 times 4, that will end up being a 40. There are no x's over a 49. And you are done. Okay, so 40 over 49. And so that's all you just keep doing over and over again. Let's go back, something a little bit more involved. So coming to these problems, I know some of you guys are making these difficult, but I promise you guys, these are the same type of problems that you were doing with polynomials in the previous unit. The only difference is, instead of setting these polynomials equal to 0 right now and solving for zeros of polynomials, all I'm asking you to do is simplify these rationals. And what you're doing is factoring using the skills that you learned in polynomials all over again. Okay, so recall that when you have, let me move this over a little bit here. When you have a trinomial, ax squared plus bx plus c, where a, your leading coefficient, is 1, the questioning technique that you're just going to ask is, what are the two values that multiply to be your c, that at the same time, those two numbers must also add to be your b. Okay, so right now my a is a 1, my b value is a 2, and my c value is a negative 63. So let me replace this c with negative 63, and my b value is a 2. So again, multiplication facts are important. So you are going to look for two numbers that multiply to be negative 63 that at the same time add to be 2. Well, I know 7 times 9 is 63, right? But I need 7 times 9 to also add at the same time to get 2. Well, if I put the negative on, sorry, not on that one, because that would not work, on the negative, well, negative 7 times 9 indeed is negative 63, and negative 7 plus 9 does give me a positive 2. So I'm going to take those values that I just found, and I'm going to put them, because that's just a little shortcut to help me figure out what these factors are going to be. So x minus the 7 and x plus 9, if I were to distribute, would give me x squared plus 2x minus 63. Again, really quick, just to show you what I'm talking about. Not that you need to do this, but just in case some people are still not understanding what FOIL means, or distribution or factoring means. X times x is x squared. X times 9 is positive 9x. Negative 7 times x is negative 7x. And negative 7 times 9 is positive 63. And then these two values, when you combine them, are going to end up being 2x. And look, x squared plus 2x plus 63, indeed, not plus 63, 7 times 9 is negative, sorry, minus 63 is what we started out with in this problem. That's the numerator of our fraction. So you are getting this problem, and you are looking to find out what multiplies to give me that trinomial. So you're working backwards, all right? So hopefully you guys are starting to see that, because we've done that a lot in the last section. So let's look now at the next trinomial, all right? Same questioning technique. We're going to do what times what gives me negative 70 is the C value. That at the same time, those two numbers have to add to be 3. So 10 times 7 gives me a 70 for sure, and I need them to subtract or add to get a 3. So I definitely need to add. I definitely need to subtract. So I'm going to put the negative on the 7. And that works. So x, a positive 10, and the other number was a negative 7, so x subtract 7. And so in so doing, the whole goal of the factoring is that there is a hope that when you finish factoring, that the factors are going to clean up and make this rational function a lot simpler to look at. So notice here, my x minus 7 matches with this denominator x minus 7. So I am now left with x plus 9 over x plus 10. So when I come over here to type it, I should end up with a correct answer. And if you were to graph x squared plus 2x minus 63 over x squared plus 3x minus 70 in Desmos, and also graph x plus 9 over x plus 10, those two would match, by the way. All right? Okay, let us go a little bit into, let's say, level 2. We're going to jump a notch, okay? So that other section, you're just practicing your factoring trinomials. Let's up it a notch, okay? So here we have a 6x cubed minus 294x over, and then we have, this is a long one, 3x4 plus 39x cubed plus 126x squared. And this time we're multiplying. Again, if it was dividing, you would switch it to multiplying and then flip, okay? And we have x squared minus 36 and x minus 7. Okay, so the first one, 66, this one right here, by the way, 6x cubed minus 294x. So it's not a trinomial, but I know from previous chapter that I should always try the greatest common factor approach. Is there a greatest common factor that can simplify that binomial? Well, let's try. So I see 6x cubed minus 294x. I know for sure that the number 2 would go into both of those because 6 and 294 is a, even number. But let's see if 6 goes into 294, all right? So let's pull out, where's my little calculator over here? Does 294 divide by 6? And 294 does divide by 6, 49. So 6 is the highest number that goes into both of them. I also noticed that there is an x cubed and an x, so both terms have, and when I say terms, I'm talking about this term and this term both have x's in them. How many x's do they have in common? They only have a single x. So I'm going to take out or factor out the GCF 6x. So if I divide out 6x between both of them, if I divide this by 6x and I divide this by 6x, well, 6 divided by 6 is just a 1, and x cubed divided by x is x squared. So I need to come over here and write an x squared. Minus, we already established that 294 divided by 6 is 49. And I'm not going to put an x because they canceled out. Because if I divide this by 6x, these x's cancel, and 294 divided by 6 was 49. Okay? All right, now on the bottom. That looks pretty, complicated, but again, don't let it intimidate you. I noticed right off the bat, all of them have x's. All of them, okay? I notice also the first term has a 3. So let me point out what I'm looking at. This term has a 3. this term has a 39 and a 126. And I know all of those are easily divided by 3. First of all, 3 divided by 3 is itself. 3 can go into 39 because both 3 and 9 are divisible by 3. And 126, I know 3 goes into 12, 3 goes into 6. So for sure, 3 goes into all of them. And they all have x's, at least 2 of them. So 3x squared is the GCF. 3x4 divided by 3x squared would just be x squared. 39 divided by 3 is a positive 13. And x cubed over x squared would just leave me an x. 126 divided by 3 is 42. And no x squares are left over because they cancel out. Times, I'm going to open this now for the next one. X squared minus 36. Now that has to, you need to remember from way back when, you guys did learn about difference of squares several times now in your high school career. But again, if you forgot from last unit, I told you guys that if you have 2 squared numbers that are subtracting, you can square root, in essence. Pretend you don't do this what I'm doing, but I'm doing that so you understand what I'm saying. You are square rooting a squared, and whatever that answer ends up being, you write it down. So in this case, it would be a. You would square root b squared, and whatever answer you get, you would get a b. And you can put a plus on this first factor, replicate it, but the replicated factor has to have a subtraction. So whether you do plus then minus or minus then plus, it doesn't matter. But as long as you have 2 numbers subtracting that are perfect squares, you can factor it out as such. Okay, so I'm putting this in yellow because I want you guys to understand that what you're doing is a visual approach, okay, or a mental approach. But in essence, you are square rooting these, okay, to help speed up the factoring process. So I know that's a difference of squares. So I'm going to put my 2 parentheses here, and I'm going to put an x and an x because I know it has to multiply to be x squared, and the square root of 36 is going to be a 6. 6 times 6 is 36, and then I'm done. Okay, and so again, this yellow that I'm erasing again, that's just the mental arithmetic that I'm having you do to be able to factor difference of squares. All right, and if you were to multiply this out, again, this here would be x squared. That would be negative 6x, positive 6x, negative 36. Notice how these are going to zero out, and you're left with x squared minus 36. The x minus 7 cannot simplify any further. And hopefully, as you're looking at this problem, you're noticing, well, wait a minute. Isn't this x squared minus 49 over here, isn't that a difference of squares? It is. So what I want you to do is rewrite this as x minus 7, x plus 7, because you square rooted the x squared and you square rooted the 49, and now you are able to cancel. So this x minus 7 will cancel with this x minus 7. Oh, so I think I need to still, let's go ahead and factor this part here because we haven't factored this. So let me rewrite it one more time. So we have the 6x, x minus 7, x plus 7. I'm going to put it back for a second. Over. Let's bring down the 3x squared. And that's that trinomial, right? So I'm going to put an x and an x. What are 2 numbers that multiply to be 42 that add to be 13? Well, those 2 numbers would be a positive 6 and a positive 7. And I'm going to bring these other things down, and then we will go ahead and proceed with all the canceling. And what I want students to understand, though, is when you guys are canceling and your rationals are multiplying, you can actually visualize this multiplication of two rationals as one big problem, and just imagine this whole line being connected. Like, you can totally do that. There's multiplication is commutative, and so imagine that line being drawn completely across. And so here we go with the canceling. So upstairs and downstairs matching factors. So x minus 7, x minus 7, the x plus 6 cancels out with upstairs x plus 6. This x plus 7 cancels with this x plus 7. And let's see what else. So this x right here will definitely cancel with one of the x's of the x squared. So we'll just get rid of this x squared. And we're left with upstairs without the ones without the strike through. We have a 6, an x minus 6 over. And then we have a 3x. And then you need to make sure that your numerical values are completely reduced. Both 6 and 3 can be reduced by 3. So if you divide them both by 3, you're going to get a 2x minus 6 over x. 6 divided by 3 is 2. And so this here is your final answer. Okay? So that's all that you are really required in doing in 4.1. It's just a lot of factoring. So make sure to practice those skills. The main factoring skills, again, that you need to recognize that you are going to repeatedly use is greatest common factor, difference of squares, and factoring using the trinomial, wherever it is that I did it, right over here, using these methods of factoring. Okay, you cannot throw those skills away or put them aside. Just continue using them. We used these in the previous unit. Okay, now when it comes to 4.2, let's see here. Okay, so here is this adding and subtracting section now. So now we have fractions. Math operations are adding and subtracting, and as you know, when you're adding and subtracting fractions, you always find common denominators. Here, the denominators 3 and 8 obviously are not identical numbers, so we cannot proceed with subtracting these fractions. So back in elementary school, you were taught to find the lowest common multiple. So if I look at the multiples of 3, 3 times 1, 3 times 2, 3 times 3, and so forth. Okay, so these are the multiples of 3, and I can keep going on forever. When it comes to 8, it's 8, 16, 24, and so far my numbers are not matching, as you can see, right? And so I need to increase the 3's. So let's see, that was 6. 3 times 7 is 21. 3 times 8 is 24. And voila, I found a common multiple. So the lowest common denominator between 3 and 8 is going to be a 24. So I need to convert those to a 24. So if I need to convert 3 to a 24, I'm going to have to multiply that 3 by an 8. And so if I do that, and actually I'm not going to use a times as that, I'm going to use a times as a dot so it doesn't confuse you with those x's. Therefore, I have to multiply this x by an 8 as well. Whatever I do downstairs, I've got to do it upstairs as well. The 8 needs to convert to a 24, so I'm going to multiply it by a 3. All right, so now let's simplify. X times 8 is going to give me an 8x over 24. Minus 7x times 3 is going to give me a 21x over 24. And so now I have the green light to combine these two fractions because the denominators are alike. I'm going to put them on one fraction. 8 minus 21, 8x minus 21 would give me a negative 13x. And if I can reduce the negative 13 and the 24 to a more simple fraction, I need to do so, but 13 and 24 can't reduce any further, so this is my final answer. So negative 13, negative 13, whoops, I am trying here. So negative 13x over 24 would be the final answer. Okay, and so that's what you're going to do. So right here on this problem, 3x cubed, those answers were still, those denominators were already alike. So 7 plus 6 gives me a 13. And then I come down here to 3x to the third power, and I'm done. So combine your fractions when they have like denominators. But of course, these are level 1 problems, pretty straightforward and simple there. So let's go back to the possibility of having something more complicated than that. So let's look at level 2 problems, okay? So here I have a 7, and it is adding with a 5 over an x minus 9. So this 7 basically is a 7 over an invisible 1. And you can see that these two fractions do not have common denominators. A 1 does not look like an x minus 9. So what I'm going to do is I'm going to multiply that 1 by an x minus 9 to force it to become x minus 9. So I have to do that upstairs as well. So 7 times x minus 9 forces me also to have to distribute. So I'm going to end up with 7x minus 63. 1 times x minus 9 is just x minus 9. Plus, and this 5 over x minus 9, I don't have to do anything with it because I'm multiplying it by 1, right? And multiplying by 1 doesn't change anything because I want x minus 9 to be the denominator. So now I'm going to bring these things together because x minus 9 is the same for both. So 7x and negative 63 plus 5 would be negative 58, I believe, over x minus 9. And then that is the final answer. So you just come over here and I'm going to type 7x minus 58, arrow down to x minus 9. I'm going to submit, and there's my answer. Let's try, oh, this is an interesting one. Some people have asked about this already. So this 3 over x minus 8 looks so closely related to this other one, but the denominators are not the same. And so students were asking, well, how can I get them to be the same? Because it looks like they're just switched around, which they are. So it doesn't matter which one you want to switch around. I'm going to purposely switch around the second one. So this x minus 8 and 8 minus x are really similar, but I'm going to force this second one to be multiplied. So this whole fraction, this whole factor, I'm going to multiply it by a negative 1. All right. And therefore I have to multiply 7 also by a negative 1. I'm in essence multiplying this by 1. People usually just don't write it because 1 is so negligible. But anyway, so 1 times this first fraction is still just going to stay 3 over x minus 8. 8, not 9. And then I'm going to put a minus. 7 times negative 1 is going to be a negative 7. And look what's going to happen. When I take this negative 1 and I multiply it by this, I'm going to get a negative 8. All right. And when I take this negative 1 and I multiply it by this negative x, I'm going to get a positive x. But if I switch those around, instead of negative 8 plus x, if instead I got rid of it and wrote it as x plus negative 8, which in essence is the same thing as saying x minus 8. Aren't those the same as that? Yes, it is. So what I'm saying is when you multiply by a negative, let me erase all this around. -1 times 8 minus x is the same thing as saying x minus 8. All right, and you saw by me distributing that I ended up with -8 plus x, so I'm just flip-flopping to make it x minus 8. So now my denominators are the same, so I can combine. X minus 8 will go in the bottom, and then 3 minus -7 is 3 plus 7, which is 10. And so 10 over x minus 8 ends up being the answer for this one. So let's write that. So we had a 10, arrow over, and have an x minus 8. And you can't reduce or anything like that on these. Okay. One more for the road. Let me see if I can find a better one. Okay, so here's a problem that we're going to do since I couldn't find one. So I just pull this from a homework set here. So hopefully when you look at this problem, your brain is sending an alert already that needs to be factored. Anytime you see a trinomial, factor. All right, so let's start here. The 3x plus 7, well, there is nothing to do with that. There's nothing more simple than 3x plus 7 because GCF is a 1, and factoring out of 1 doesn't do anything. Same goes with x minus 7. Those factors cannot be changed. The numerator 7x, same reasoning, can't be broken up. But that trinomial, let's do that questioning technique. What times what is going to give me that C value of 14, and what plus what will give me that middle value of -9. And I know that a -7 times a -2 indeed gives me 14, and does it also add to give me -9? Yes, it does. So let's put that -7 and -2 value into some factored format. Okay, so now we look, does this denominator match this denominator? Well, almost, right? But this right here, we don't have that on the other one, so we need to force it to have it, right? So because it's not alike, I'm going to say, well, I know it's not alike, but I'm going to go ahead and put an x minus 2 there. Therefore, I'm going to have to put an x minus 2 upstairs as well. And now when I look at it, can I see these denominators being alike? Yes, they are. So for your final answer, for this section, you don't have to multiply and do all that kind of stuff. As long as your denominators are the same, x minus 7, x minus 2, which they are, just type what you got into your delta math and you are done. Plus 7x. Like, you can type this out and it will accept it as an answer. I know some students are taking it further, and I don't know why my screen's not moving, but they take it further and they distribute. So they're doing, 3x times x and so forth. Let me get my cursor here. It's not working. 3x times x, 3x times 2, 7 times x. So some students are doing that, and it's totally fine. You're going to get that answer too. That's correct. You're going to have to do that eventually in this chapter. So if you feel like practicing and distribute, so 3x squared minus 6x plus 7x minus 14, and then add that 7x that comes with it. Okay, so you FOIL and then that bring along that 7x, and then combine the like terms upstairs. Your delta math will also accept that as your final answer. So my like terms, 3x squared doesn't have any like terms. -6 plus 7 is a 1x, and 1x plus 7x will give me and 8x, and then bring down the minus 14, and then x plus 7, x plus minus 2. Don't ever multiply out your denominators. Just leave it alone. Okay, so if you want to take it a step further and distribute, that also will work. But I just say stop here. Honestly, why waste time if it's not requiring you to do any simplifying yet? If it's not requiring you, don't do it. Okay? All right, that's it. I hope you are less stressed, that this will help as I reviewed all the factoring techniques that you need and how to find common denominators when adding and subtracting rational functions. Or, yeah, expressions, I should say. Thanks for watching, guys and girls. Bye.